guys, welcome to our talk on Android testing APIs, and today we're going to show you how you can write higher quality apps using automated tests. My name is Stefan Linzner.
I'm Jose Alcerrica.
And I'm Jan Felix Schmarkheit. And we are developer programs engineers on the developer platform team here at Google. And you might have seen some of the sample code and some of the libraries that we've been working on. In particular, the Android testing support library is something that we've worked on. And with that, I will leave you with Stefan, who's going to talk a bit more about how Android testing has evolved over the last few years. Thank you.
Thank you, guys. So almost 2 years ago, when we started thinking about how we can make developers more productive, how can we enable you guys to write higher quality apps? One thing that repeatedly came up was automated testing. But if you look at the testing APIs, what you will find is some of them have changed in API level 3, which was Cupcake, and most of them have been around since API level 1. So what that means is, in the meantime, Android has evolved a lot, right? And I'm so proud of what we've achieved in the last 5 or 6 years in Android, and I'm pretty sure everyone in this room is. But we haven't evolved in the testing space, and that's what we wanted to change. We wanted to make testing easier, and we wanted to have a better testing experience across the stack. So since then, we've made a lot of progress on many levels of the stack, and we've created a new suite of tools and frameworks to enable a better testing experience and make it even fun to write tests. So we have Android Studio and Gradle, which added amazing new features like the new unit test support, which allows for faster development cycles and makes you more productive. We have new ways to write and run tests. And we also now have compelling ways to display test results and code coverage reports in Android Studio. And now with Android Studio 2.0, you can even refactor across unit and instrumentation tests, which is amazing. But we went even further. So we ended up creating a full support library for testing called the Android Testing Support Library. This library contains all of our testing APIs, and you can just apply it to your project and get easily started with testing. But even more importantly, this library is unbundled from the platform, which means we can update it at any time, and we can iterate faster, and we can fix bugs more quickly, which was a problem before. On top of that, we also created a new testing library called Espresso, and this addresses actually one of the biggest pain points that we had in Android testing for a while, which is UI testing. And Espresso, you will see that if you start using it, has a really nice, beautiful, concise, and fluent API, which makes for frictionless testing. And with that, I'm going to hand back to JF. He's going to talk about the CodeLab app that we've built to show you how you can use our testing APIs in action in your project.
Cool, thank you, Stefan. So the app I'm talking about here is actually part of a CodeLab that we are going to be referring to throughout this presentation. At the end, I have some links and some resources. You can actually check it out and see exactly what we have done. So the app we wanted to build was meant to be, was meant to showcase the best practice for testing today. How you should be using testing in your Android application. So what we have built is a very simple, very standard note-taking application. You can view a list of the notes that you have in your app. You can add a new note, which means you can also take a photo, attach it to your note. You can click on a note and it opens up and you can see its full content. And we have some navigation in there as well. And as you can see, this is very much a stock standard Android application, probably quite similar to the way you've built an Android app before. We're using a recycler view to display the list of notes. We're using a system intent to open the camera app to take a photo using the system camera application. And we have a navigation drawer in there as well with the menu options. Just remember, the key here was to create an application that shows you how you can, shows you the best practices for Android testing today. So as part of that, we were thinking very carefully about the architecture that we use for our application. Let me be very clear here. MVP is mono-represent architecture, obviously, but there are many other great architectures out there. And it really depends on your use cases and your application to select something that works for you. Just remember, the key part for any architecture is that you can separate the different parts, the different components of your application from another. So you can test them independently, and you can maintain them independently as well. So in our case, for our application, that was the model view presenter architecture. And the way this works is that we have the data storage, the list of nodes at the model. We have a view. This is where the actual Android magic happens. That's where we deal with the recycler view and display the actual nodes. So for example, if you want to load in a list of nodes and display them on the screen, the presenter talks to the model, loads in the list of nodes, and tells the view to display it. And then the view talks to the recycler view and then displays it. So just remember, the key part here is to separate the different areas and different components of the application. And this makes it really easy and really useful for testing. Now I have Jose coming up next, telling you a bit more about testing and independent components.
Thank you, JF. So JF mentioned testing in isolation. In order to test in isolation, you need to be able to create a hermetic environment. So before talking about the types of tests, let's talk about hermetic testing. Why do we need hermetic testing? Because there's something worse than having no tests. That's having flaky tests. I've seen this slide so many times, I didn't remember it was funny. A test is flaky when it fails sometimes. So if a test fails just 1% of the time you run it, you will submit your code, submit your test, and in 3 weeks you'll get a call or you get an email saying something went wrong because this test failed. So you'll start your investigation, you'll log in into your Jenkins instance if you have one, and after 15 minutes you will say the famous last words, it's probably just a flaky test. That's something that you should never have to say or hear. So in this code lab, in this project, we decided to, we had an objective to reduce flakiness as much as possible. So the first thing we did was to isolate from external dependencies. External dependencies are one of the most important sources of flakiness, especially the network, for example. Because the network can fail in network calls when you talk to your backend API, can fail in many steps. Your Wi-Fi, your ISP connection, the server has to be on and working, but also other external dependencies to our code, like storage, all the devices, sensors, the camera, etc. So what we're going to do is replace the components that talk to these external dependencies with fake implementations that are going to intercept that and return fake data immediately. For that, we could use something like dependency injection framework like Dagger or Dagger 2, but we found something that is simpler. Flavors, product flavors, is a feature in the Android Gradle plugin. You're probably familiar with it because this is what you use if you want to create different versions of your app sharing code base. So it's very common to see free versus paid dimension for flavors. In this case, we have prod and mock. Prod is your production version, the one that you distribute, and mock is the one that is going to use this fake data. If you open the project with Android Studio and you look at the build variants window, you'll see that we have 3 variants. That's because we are filtering out mock release because it makes no sense and we don't need it. If you look at the Gradle tasks list, you'll see that there's no install debug anymore. So now we have to choose which version we want to install. We can install mock debug or prod debug. To run tests, we usually use instrumentation tests. We usually use connected Android tests. But we can now also choose what version to test against with connected mock debug Android test and connected prod debug Android test. So let's see how it's done. First, you create a source set per flavor. So we have prod and mock. And we also have another interesting source set, Android test mock. This is where you put the tests that only make sense for the mock version of your app. Check out the code to see why we use that. This is where the actual replacement happens. The injection class lives in both mock and prod source sets. So that is the class that is going to be replaced depending on the version that you're using. Also, we put the fake implementations in the mock source set. This is great because it's actually going to hide these classes from the production app so that you can't use them by mistake. Zooming in a little bit, this is the injection class of the mock flavor, of the mock source set, rather. It has two methods. Both injection classes look the same from the outside. They have the same public methods. Provide image file is the method that we use from the component that talks to the camera. So we're going to return a new fake image file implementation. That class, the only thing it's doing is returning a string, a path to an image file that we preloaded. So it's a fake image, really. Provide nodes repository is the method that we use to create the repository. So if you're using the mock flavor, it's going to create an actual real in-memory repository, but we're going to inject a fake dependency. In this case, the fake node service API implementation, that's a very Java name, I know, is going not to start any HTTP connections, but it's just going to return immediately a JSON file in this case. And that's it. That's how we set up. That's how we set up a hermetic environment. Is it actually 3 to 12? That'll be pretty cool. Yeah, more or less. All right. This has some interesting side effects. Mock mode. Using the mock flavor is interesting if you are developing your app. You usually do manual testing, right? If you're developing UI specifically. You change something in the UI, you deploy, and then you test manually that what you've done works. If you use fake data, this iteration is going to be shorter, so your development is going to be faster. It's also good for concurrent development. So if you don't have a backend API yet, you can use fake data in the meantime. We're not only going to run instrumentation tests against the mock flavor. We can also use the production app because it's going to give us very nice end-to-end tests if we want to test the whole project from the backend to the app. This test is going to be obviously more flaky, but you don't have to run it very often. You can run it every 24 hours, or it's actually a very nice pre-release check. So before uploading to Google Play or your distribution channel, you run this test against prod to make sure that everything works well. So now that we have a hermetic environment, we can start talking about tests. And the first type is unit tests. They are fundamental for a good testing strategy that then can be completed with integration and UI tests, a small number of end-to-end tests, and other tests like monkey runs, robot runs, or even performance tests that JF is going to talk about later. The unit tests are also called local tests because they run on your local workstation, so they are really fast. But they're also fast because they are small. Unit testing is about making sure that the individual parts of your code work as expected. So the unit tests must be small, and you should be able to run thousands of tests in seconds. The problem is that because we are running on our workstation, we don't have access to the framework. We don't have access to Android. So the problem with Android is that we see this a lot. We just have huge activities with all the code typed into them, or huge fragments. So this is horrible for unit testing. Don't be this developer. Be this other guy. He unit tests his business logic, and he's really happy about it. Business logic means what your app actually does. So if you have a filtering app, a photo filtering app, the business logic would probably be the algorithms that you use to filter the images. Only if you have small dependencies with the framework, you can use this nice feature that we added to the unit testing support in 1.1, the mockable Android jar. The Android jar is a file that you download with the SDK manager, and it looks like Android from the outside. It has all the public methods and all the public classes, but it's actually empty. So if you have a small dependency on Android, you can use a mocking framework like Mockito to mock these classes. We have an example on GitHub that is mocking shared preferences. So if you don't want to wrap that class, you can use Mockito and on your unit tests and run them on your local workstation. So let's see how the unit tests look like. They live in the test folder. We have five classes. If you open, well, the first thing you have to do is go to the build variants window and choose unit test as the test artifact. This is going to enable the unit test, but also refactorings and something else. But this is actually going away. In Android Studio 2.0, you don't have to do this anymore because both instrumentation and unit tests are going to be active, so you'll be able to refactor across both test artifacts. If you know what I'm talking about, you know this is huge. This is how a normal unit test looks like. It's a JUnit4 test. It has the add test annotation, the name, and it's as simple as it gets. The add new node method is called on the real presenter, and then we're verifying that the mocked view, in this case, was called via that method, the show add node method. Verify is a Mockito API, by the way. In order to execute it, you can right-click on the method, right-click on the class, or right-click on the file, and in the right-click menu, you just click on Run. From Gradle, we simply use test, because your unit tests are supposed to be fast, and they should pass really fast. So you don't need to filter one. So we just run all of them all the time. In the Code Lab, we use a test-driven development approach. This is about creating the unit tests first, and the unit test will act as a contract. That is going to say how your app behaves. So the first thing you do, you create the unit test, you see that it fails, then you implement the behavior on your app until the test passes. And then you move on to the next test until you have something like this, a glorious list of tests all passing. So with all that we've talked about, the fact that we have an architecture that in this case is MVP, but you can use whatever you want, the fact that we have the hermetic testing in place and that we are using unit tests and TDD is going to lead you to a very, very healthy code base where adding new features is super easy. It's a matter of adding a unit test, a couple of methods in an interface, and then Android Studio is actually going to tell you where to fill in the gaps. Great for maintenance as well. You don't need to be afraid of refactorings anymore because you are covered by tests. And you'll see that instead of adding to your technical debt every time you modify your code, all the pieces are going to fall into place. So to finish off, I want to talk about a hybrid type of tests. These are the unit tests that run on a device or an emulator. They are by definition integration tests, by the way. So we call them unit Android tests because we are good at naming. These tests allow you to test things like your parcelable implementation or your SQLite integration, and they're actually invisible. You just upload the tests, you run them, and then the results come back. So you don't actually see anything because they don't open activities, they don't open fragments. If you want to test those UI elements and the UI interactions, Stefan is here to talk about UI testing with Espresso. Thanks.
Thanks, Jose. Great. Yeah, so let's talk a little bit about UI testing. So yeah, I think the previous part was great because it showed that we can implement all our business logic, and we can verify its correctness using a unit test, and then we can move on to a high level of testing and write some UI tests for it. But the other thing that it shows, and you will actually see that if you do the code lab, which I, by the way, hope you all do right after these sessions, go down there downstairs, is that we use the IDE to generate most of the code for us. So because if you look at the test as your specification, and if you do TDD, you can use the IDE to generate almost all the code for you, and you just fill in the gaps. But it also shows how you can use meaningful abstractions and use a unit test to spec the behavior of your system, how your objects interact, how they send messages to each other, how they behave. But we can apply some of these same patterns to UI testing, and we'll look at this now. So UI tests should be a crucial part of your development strategy. Like essentially, they test your application through its user interface. It's already in the Word. And what that also means is that these tests have to run on an actual emulator or device. And the great thing about them is they will give you a lot of confidence in your application because you can run on a wide variety of configurations on emulators. And you can now even use Cloud Test Lab to run on real devices in the cloud. And so for the next release, you can just sleep well because you know your app is just going to work across all these different configurations. But I think I lied a bit because it turns out that UI testing is actually quite hard to do. And writing a reliable and non-flaky UI test before Espresso, it was a challenge, and many of you, I'm sure, have experienced this. And this is essentially why we created Espresso, because we want you guys to focus on being productive, on writing code, implementing new features, maybe even focus on a test, but we don't want you to fix your flaky tests. And what Espresso will give you is a nice, fluent, and concise API which you can use to hide almost all of the complexity that comes with writing UI tests. So when we started creating Espresso, we tried to look at UI testing from a different angle, right? We didn't want it to focus so much on implementation details like activities and fragments. Instead, we took a step back and we thought, okay, what would a user do? And if you think about it, what you do every day if you interact with your device, you pick it up, you'll find some view on the screen, then you'll perform some action on it. You might click on a button, swipe, and then you observe some UI state change. And this is essentially how our API, how our Espresso API looks like. So we have the onView method as the main entry point, and then we can just use a view matcher to tell Espresso to find us a view in the current view hierarchy. And then once we have that view, we can either perform a view action on it, or we can verify a view assertion like a state change in a UI. And a view action in this case would be something like a click or a scroll. The good news is that we created all the view matchers, actions, and assertions for you, and I'm pretty sure the ones that we have cover like 90% of the cases. But the great thing is all these three are extension points, and they make Espresso very customizable, and you can actually tailor it to your needs by writing your own matchers, actions, and view assertions. But now let's look at how you would actually write an Espresso test for your application. But before we dive into the implementation, let's have a look at the Add Node feature from the Notes app. So this is a UI flow I'm going to show you, and we're going to implement it afterwards. So we start on the main node screen. Then the next thing we want to do is we want to click on a button. This will bring up the Add Nodes fragments where we can type in a title and a description. Then we can save the node, and this will bring us back to the previous screen. And as you can see, the node is displayed, the new one is displayed on the main node screen, and we want to verify that in our UI test. So yeah, let's write a test. So the first thing that you have to do is you have to create the node screen test in your Android test source set. And then you have to do two things. The first thing is you have to tell JUnit that you actually want to use the Android JUnit 4 runner. And then the second thing is you have to assign a test to a bucket. This is something that you don't have to do, but we recommend to do it. Because especially if you run on a build server, you don't want to run all the tests at a time. You just want to run either the small, the medium, or the large ones. And this is in particular important for the large ones because they will run a long time. So once we've done that, we need to set up the stage. We have to set up our test fixture, and we do that using a new API in the Android testing support library called activity test rule. And so you might have heard of rules. They're not a really new concept. They have been around a while in JUnit 4, but this is essentially an API you can use to create reusable components which you can use in all of your tests, and they reduce boilerplate code. And that's exactly what we can see here. So in order to use activity test rule, the only thing that you have to do is you have to create an instance in a public field, annotate it with the @rule annotation, and then what this will do is it will start the activity before each test and will finish it after each test run, which is great. And now we're actually ready to exercise our UI. And here's how you do it with Espresso. If you remember what I just showed you, the first thing that we want to do is we want to click this button at the bottom right of the screen. So the way we do it in Espresso, we ask Espresso to give us the view for the corresponding @node ID from the current view hierarchy. And we do that by using a with ID view matcher. And Espresso will return us that view, and then we want to perform a click action on it. And Espresso will get the view, click on it, and then the @nodes fragments will show up. And then we want to type a title and a descriptions in the corresponding edit text fields. And again, we use the same entry point on view. We use a with ID matcher again to get a hold of the title and description views from the view hierarchy. But this time, we don't click on it. We just use a type text action to type some text in the title and a description. And then we want to save the node. And this works pretty much the same like the first step. We get a hold of the view using a with ID matcher, and then we perform a click action. And the last thing that we want to do is we want to actually verify that the node that we've just added to our model is displayed on screen. And this time we're going to do things a little bit differently. We use the onView method, but instead of matching a view by its ID, we can also use text and tell Espresso, give me the view from the view hierarchy which contains these text. And then we can use the check method to verify that the view is actually displayed on screen. So if you look at this UI flow, it's not an easy UI flow. But if you look at the code, it looks really easy, it's really readable, and there's no implementation details. There's no activities, no fragments. You essentially don't have to deal with those details anymore. And in fact, Espresso only cares about views and windows. That's all it cares about. And it hides most of the complexity and most of the UI synchronization from you. And now, of course, you want to run your test. This works pretty much the same like Jose showed you with the unit tests. So you can either right-click on a test class and click on the play button, or you can also do it on a method level from the test class. But what this will do is it'll create two APKs for you, a test APK and an app APK. It'll deploy both of them to your device, and then the test APK will instrument the app using instrumentation and exercise its UI. So you can, of course, do this from Gradle. This is something that you wouldn't use in your local development flow, but it's something that comes in very handy if you actually run from a build server and if you use a CI server, which is something that I think most of you guys do anyways. So, and now at this point, we need to wire up our Android code with our architecture, right? And the good news about this is because we already implemented all the logic in the presenter, our Android implementation will be much simpler. Often it's just setting some text on a text view field, and often it's very simple. And the other good thing is because we know that everything already works because we have the UI tests for the presenter, this is a great approach to attempt testing in general and combine the unit testing with the UI testing. And at one point, you'll actually go green, your test will pass, and then you will see something like you can see here on the right. And I've been working on this since many years now, and I'm still fascinated if I see those tests run on a device. And you should really try it out, because it's a lot of fun to write UI tests with Espresso. So let me summarize. Espresso gives you frictionless UI testing. Espresso is really reliable. You will see that if you switch to Espresso, or if you start using it, you will see your tests will be much more reliable. They're also more readable. They're almost like a UI spec. So think about onboarding a new member to your team. You can just point them to the test. They can read through the test. They can almost figure out the whole UI flow just from your test. And maybe they get excited when they see how easy it is to write a UI test, and it's easier to onboard them to write UI tests in the first place. The last thing I want to mention is Espresso is blazing fast. We do all the synchronization for you, and we know when to execute the next view action immediately after the previous one has finished. And you will immediately notice this if you have a lot of tests and if you switch over to Espresso. So to summarize, Espresso makes for a non-flaky test, and you should really try it out because it's an amazing framework and it's a step forward in UI testing on Android. And with that, I'm very excited to have Jay to talk about some of the newer stuff that we've been working on, because now that we have all the low-level APIs, we really want to take a smarter approach to testing, and we want to build the high-level tools which sits on the low-level APIs to enable more powerful use cases.
Cool. Thank you very much, Stefan. So we've had Jose talking about unit testing as the fundamental way we should be testing our applications. Then we had Stefan talking about integration into UI tests, being able to test the actual Android part of our application. And as you've probably all realized by now, these testing tools have matured quite a bit over the last few years. So now is the time to start thinking beyond simply verifying the functionality of our application. Let's think about performance testing. And this very much sits at the top of our testing pyramid. You know, we take advantage of all the great testing tools and all the platform features that are already out there to build our performance tests. So performance testing today, I'm sure many of you have experienced this yourself, is very painful. Traditionally, you have a few lower spec devices, for example. You have a QA team that has access to those. Maybe you have a slower network at home where you just try to run your application and see if it performs OK, or if anything is a bit slower than it should be. And the problem with that is you can't easily reproduce any of this. It's really hard for you to track trends to see how your application is performing, right? And especially if you've automated the rest of your tests already, why can't we automate our performance tests? And why can't we take advantage of the existing tests that you have already written for this particular part? Let me introduce the performance testing harness. This is actually part of a great code lab that we've put together that I highly encourage you to check out after our talk. The way this works is that we have a new custom Gradle plugin that contains a task that you can run, which you use to run your performance tests. The trick comes from a special test listener that sits in your test APK. The basic idea is that we capture some additional statistics and some additional log files as you are executing the tests. So for example, we can track the rendering performance, the logcat output for each of the tests as you're running it, capture it on the device, copy it back to your development machine, and then do some analysis on it. The key part of this are some custom JUnit test rules that we have added. Stefan talked about rules already. These allow you to add some additional functionality to your existing tests. So here we have 3 rules. The first one basically runs the dumsys graphics info command, which you might have already used if you've tried to track down some jank issues in your application. It allows you to gather some statistics on, for example, the number of janky frames that you had and the rendering performance. We can do exactly the same for the netstats command, which allows you to track your network performance, the number of received and sent packets, for example. And we can also capture the logcat output individually. So just remember, these rules are applied to each test as it's being executed. So for each test, we can now capture the graphics performance, network performance, and the logcat output. And this is pretty powerful. And this is all being executed through this new test listener that gets added to our test APK on the device. And that's where we can capture some additional statistics as well, such as a systrace output if you want to track down any other performance issues. This is what it looks like if you're actually running the test. First of all, we have to run our new custom task, run local perf test. And then as the test is being executed, our listener captures the logs for each of the tests. In our case, we only had one test we have executed here. But you can see that for each test, we have now a log file we can go back to and then analyze further. And of course, there's the systrace file as well that gets captured for the entire test run. And this all happens automatically for you. And I think this is very powerful. So here's an example where our test actually failed. And you can see that we had an excessive number of janky frames, 91%. And this is clearly a problem. This was one of our existing tests that we had, and we simply marked it as a perf test and ran our test harness over it and captured all these statistics. So we had 91% of janky frames. Janky frame means that the frame took longer to render on the device, so it appeared a bit janky on the device. So our test failed. Instead of having to go back, getting the device out, having to reproduce it, and trying to see what's going on there, we have captured all the log files already. We have the systrace file there as well. So we can go straight back to the logs we have captured to see what the problem was and maybe even fix it straight away. And this is a great way to scale up your performance testing if you think about it. Just imagine where you can take it from here. Right? Running it on one device, yeah, that's OK. You can probably already do that. But imagine scaling this up and running this as part of your continuous integration tests. Right? What if you can run all these performance tests as part of your, for each commit or for each build that you're creating? And this is very powerful because this now allows you to capture statistics and trends as they develop. You might even be able to go back all the way to one commit that introduced some performance issues that didn't come up until later on. So no longer you have to rely on just simple manual performance testing. You can use our testing harness to automate some of the work for you. And I would like you to think about, this is just the beginning, right? There's so much more we can do with this, right? Now that our testing tools have matured, we can start thinking about other ways we can test and improve our performance in our applications. We can look at battery usage, for example. We can look at the network performance as well. This is very much just the beginning. So my point here is really that we should now be starting to think about smarter testing, performance testing, and there are many other ways we can automate some of the things we're currently doing manually to build better apps and make it much easier for us to verify and test our applications, to delight our users and give them a great experience as we work on our applications. With that, I highly encourage you to check out our code labs. They are great. First of all, the Android testing code lab. This is the one that you have seen throughout this entire presentation. So we have a great code lab that we've put together that shows you how we've used the MVP architecture, how we're using test-driven development, and how we're doing the unit testing and the UI testing in a great, concise application. You can check this out in the code lab area downstairs, and they're online as well. If you're more curious about the automated performance testing that I've talked about, and you want to see it in action and have a play with it to see how you could use it to actually track down a performance issue, check out the automated performance testing code lab. Here are some amazing resources we've put together. The code labs are all available online for you to try out at home or later on your laptop as well if you like. We also have some great samples out there that show you everything from basic unit testing to much more complicated espresso testing. So definitely check this out on GitHub. We also have a great project called the Android Testing Blueprint. And that shows you how you can integrate many different ways of testing into one great project. For example, the unit and the UI testing that you've seen today. And of course, we have the ATSL, the Android Testing Support Library that we've all been working on. So definitely check out the great documentation for that as well. And with that, I would like to thank you very much. It's great to see so many people interested in testing here. We'll be around in the office hours area, and we have Stefan joining the Android Tools panel, the fireside chat this afternoon as well. So you can definitely find us if you have any questions. And I think with that, it's time for lunch. So happy testing.